Here is a question on integration, and I have been informed by a student to get an answer to this question in my class, and this is what I have. I'm told to integrate 24 sine x cubic, and this is divided by 1 minus cos x, and we have cos x plus 1. So this is what we have, and we are supposed to integrate this. And of course, this sign means integrate. Any mathematician in an environment in as far as mathematics is concerned. So I'd expect us to first get the first trigonometric identity that we are almost using everywhere in our daily lives in terms of mathematics. And that states that the cos squared x, if I may use x for that matter, plus the sine squared x, the answer must be equal to 1. So the cos squared x and the sine squared x should be equal to 1. So I can decide to make the sine squared x the subject of the formula, and I'll just take this on this other side of the equal sign. And you must have also been told that the tan x should be equal to sine x over cos x, if I am not wrong. So that then translates into something different, and you're going now to see what you may be able to have here. So you're going to have the sine squared x being equal to 1 less the cos squared x. You see, at the end of the day, you only have sine and cosine here. So I'll actually look for any trigonometric identity that can capture those two very important parts. And we have what you call the tan x being equal to the sine x over the cos x. And of course, the cos squared x plus the sine squared x being equal to 1. So you can decide to make the sine squared x the subject of the formula by taking the cos squared x on this other side of the equal sign, that becomes 1 minus cos squared x. So these are a very important part of this working. Let's get back to this denominator. We have nothing to do with what you call the numerator. So let's try and see what you can do here. So of course, this one has what you call a quadratic identity, the third quadratic identity, which says a minus b, then a plus b. This must translate into a squared minus b squared. Wow, so I think you know this. You must have been told about three very important quadratic identities, which state that a plus b, which is squared, must be equal to a squared plus 2ab plus b squared. And of course, you've also been told about a minus b squared, which states that you're supposed to get a squared minus 2ab plus b squared. Okay, and then you can come back and now see what you can do here. Let's come back to this. I think you can be able now to expand this using this third quadratic identity. So we shall have the integration of 24 sine x cubic over. So because of that, I think if we take this and then open the brackets, we can be able to actually expand and have this. So let's get the one that has a minus and then be able to just square those parts. So we shall have 1 squared giving us 1 less this squared giving us cos x squared. So then we shall come here and say that now integrate 24 sine x cubic divided by, okay, and this is going to be now equal to sine squared x. So sine squared x. Why? Because I have told you that when you take this on to this other side of the equation, you're going to have sine squared x being equal to 1 minus cos squared x. So this is the same as sine squared x. So where there is 1 minus cos squared x, just put sine squared x. So just substitute, because this and this are the same, they must be equal to this. So just substitute that part with that. So if you decide to actually work out this, but you're going to have an integration of course, sine squared x can go into sine cubic x once. So you're going to have 24 sine x. Wow. You can be able to get this out of this because you should be able to integrate with respect to change in x. So the constant here, and of course now what we call the coefficient, can be able to get taken out of this part. So that we shall be able to have 24 integrate sine x with respect to change in x. So that means this one gets affected because it has what we call a variable x. So then you can be able to come here and say that sine x getting integrated can give us negative cos x. I think from what you call further trigonometric functions, you can be able to get this very clearly. And now we can be able now to come and have now 24. So into, of course, now we have integrated this to get negative cos x. We close the brackets, and then we say plus a constant c. So in any integration, there must be a constant getting added to your working. So that now our final answer is going to be negative 24 cos x plus a constant c. So that becomes your final answer for that question.